Okay, good morning. So today I'm going to answer the last five questions which was not answered in the review. Okay, so although the answer was given but the equation or the solution was not. Okay, so ngayon tatry natin solve. So let's try to answer question number 6. So a box slides down a 40-degree inclined plane. The mass of the block is 40 kilogram and the coefficient of kinetic friction between the two surfaces is zero point 0.3. If the length of the ramp is 10 meters, what is the total work done on the system? So we are talking about the total work done on the system, not just the work done by the frictional force, not just the work done by gravity, but the whole work done on the system. So that means that's the sum of all of the works done on the system. So the first thing that we need to do with this problem is that to draw the problem. I-draw natin diagram. Okay. So we have, let's assume, inulit ko, hindi naman kailangan eksakto ang diagram natin. Okay. As long as the data are there. So we have here theta to be 40 degrees. Let's say this is the block that is moving downward. So may motion siya pababa. Now, the given, so let's try to draw the given. The given in the problem are, of course, the angle theta, which is 40 degrees. We have the mass of the block, which is 40 kilogram. We have the coefficient of kinetic friction, or that is mu s, to be zero point 0.3. The length of the ramp, which is 10 meters. So let's say that is L, is 10 meters. And what is required in the problem? Required in the problem is the total work done. So total work. Or we could have this as total work equal to the work done. So we have no force acting on the object rather than gravity. So the work done by gravity minus the plus the work done by friction. But of course, the work done by friction is negative, so it will become subtraction. Okay. Now, we need the work done, total work done on the system. So that first thing that we need to do is to put the forces on the diagram. What are the forces acting on the diagram? So as we could see, we have multiple forces acting on the diagram. The first thing being, the, of course, weight which is downward. So we have, this is not work, this is weight equal to mass times gravity. Next is the normal force. The normal force which is always perpendicular to the surface in question. Then we have frictional force which is always against motion. So motion natin is downward. Frictional force is upward. In this case, this is sliding friction, so this is kinetic friction. Okay. So there are no other forces. We don't have any other applied force on the object. So as I mentioned in one of my videos, the next thing that we need to do is to draw a Cartesian plane. So to draw a Cartesian plane, this is always perpendicular to the surface. The x-axis should be perpendicular or parallel, rather, it should be parallel to the surface. So we have here the x-axis, and the y-axis should be perpendicular to the surface. So, and dito si y-axis. Then we redraw the Cartesian plane. So let's try to redraw the Cartesian plane and try to draw the forces on it. So we have your y, we have your x, then redrawing the Cartesian plane. We redraw the forces acting on it by starting at the origin. So we have normal force going up. We have frictional force against motion. And we have weight going down, which is mass times gravity. Okay. And finally, in our diagram, we need to straighten up the Cartesian plane. So itayo natin si Cartesian plane. Ito si y, ito si x. So the Cartesian plane so ito si normal force. Once again, so this is upright na siya. Frictional force going to the positive x-axis and weight, which is equal to mass times gravity. So 40 degrees theta, which will also give theta over here. So that means we have here theta, which is moving away from the negative negative y-axis rather. So ang kulang natin is the components of weight. Kasi hindi natin siya basta-basta maia-add or subtract sa F sub n or yung ating normal force saka sa frictional force. So let's try to redraw. So we have here okay, so we have here the y component or the x component of weight, and we have here the y component of the weight. Now wx from the diagram, which is can be transposed on this side, so it's the same length, the same magnitude that wx over on the from the origin. Parehas din siya dito, so same length siya, so same magnitude. So wx is opposite theta, so that means that wx should be derived from the sine of theta since opposite siya. So that means wx should be w sine of theta. And of course wy, if this is beside the theta, so that means that is beside is adjacent, so that adjacent is correlated to cosine. So wy should be equal to w cosine theta. So we now have to have the components along the x and along the y. So we could now solve for the summation of forces along the x and summation of forces along the y, because that is what we need to solve for the total work done. So how do we get the summation of forces along the x? Right, along and along the y. The summation of forces along the x is wx minus friction. Wx is positive since Wx is downward and the motion is downward. So Wx or the weight along the x-axis should be positive and friction is negative. But of course, you already know that friction is always negative since it's always against motion. And of course, they have the summation of forces along the y, which is along the y, weight along the y, normal force going up. So there are no motions along the y. The motion is only along the x. So we could assume a positive and a negative. So let's make F sub n or the normal force to be positive, and the weight, since that is going down, that would be negative. That is equal to 0. So the normal force Fn should be equal to the weight along the y-axis, since we could transpose this on the other side. And weight y, so we have F sub n equal to weight y is mass times gravity times cosine of theta. Since Wy is W, cosine theta. So, saan natin gagamit yung normal force? Normal force, magagamit natin para ma-solve natin friction because we don't have a value for frictional force. We only have the coefficient of kinetic friction. So, para makuha natin si friction is equal to Fan. So, coefficient of kinetic friction times normal force. So, friction is F-U-N, Fan. So, ano si Fn? Fn is mg cosine theta. So, the frictional force should be equal to mu k times mg times cosine of theta. So, yun ang ating frictional force. Now, we could get the summation of force along the x. So, summation of forces along the x. Once again, that is Wx minus frictional force. Wx is mass times gravity times sine of theta minus frictional force, which is coefficient of kinetic friction times mass times gravity times cosine of theta. Okay. So what we need is the work done on the system. So the work done on the system is Wg plus Wf, or another formula is weight is equal to the force multiplied by displacement. So that we could use. So the work done on the system should be the summation of forces along the x multiplied by displacement. So kailangan si the summation of forces along the x, which is eto siya. Masosolve natin. Summation of forces along the x should be equal to factor out mg, that is mg sine of theta minus mu k cosine of theta. Okay, so we have, going back, summation of forces along the x equal to mg sine of theta times mu k cosine theta. So we could now solve for mg. So summation mg is, mass is 40 kilogram times gravity, which is 9.8 meters per second square, times the sine of theta, which is 40 degrees, minus mu k, which is 0.3, times the cosine of 40 degrees. So summation of forces along the x should be equal to 161.89 newtons. And we have total work done on the system using that formula. The total work done, that's 100, summation of force along the x, which is 161.89 newtons, times displacement, which is 10 meters. The total work done on the system should be equal to 1,618.9 Newton times meter, Newton meter, or that is joules. So this is the work done on the system. Okay. Next, number 7. So we have a 25-kilogram roller coaster starting from rest at a height of 50 meters, goes through a 10-meter high vertical loop, and then is caught in the end by a spring with a spring constant of 5,000 newton per meter, which is 5 meters above the ground. What would be the compression on the spring? So here, if we try to redraw, okay, the diagram, let's try to draw it first. It starts at 50 meters. Okay. It starts at 50 meters. It again drops to a certain height and then creates a loop 10 meters high and then ends somewhere here. So the loop doesn't have any effect. Okay. We could, as I don't know if I have mentioned it before, the loop is not can be disregarded because if we have here point A and we have here point B and we have here point C, the total energy at point A should be equal to the total energy at point B should be equal to the total energy at point C. So we have the total energy at point A, total mechanical energy, should be equal to the total mechanical energy at point B should be equal to the total mechanical energy at point C. Or we could skip B, go directly to C. The total mechanical energy at point A should be equal to the total mechanical energy at point C. Okay? So that means those are the things that we need. Now, if we put in the given in the problems are, of course, the mass, which is 25 kilogram. Then we have the height at point A, which is 50 meters. Okay, let's put in the height at point B. Height at point B, which is 10 meters. The height at point C, which is 5 meters. And the spring constant K, which is 5,000 Newton per meter. What is required is the displacement X. So, the required, ano yung compression niya sa X. Now, to solve this, let's use this formula. The equation that we will be using is the total mechanical energy at point A should be equal to the total mechanical energy at point C. Solution? The solution should be, let's try to get the total mechanical energy at point A and the total mechanical energy at point C. Ano ba meron sa A? So, wala siyang initial motion. So, that means that what we have are just the what we have is the gravitational potential energy only. So, only P, E, G should be present at point A. At point C, since it is compressing a spring and at a certain height, so meron siyang height, so meron siyang PEG at point C. Okay, so as nasa compression na siya, sa compression na tayo. So sa may compression na X, meron siyang height. So meron siyang gravitational potential energy. Now, we will assume that after the X compression, wala na siyang velocity. So that means that at X, meron na lang siyang elastic potential energy. PEG at point C. PEG at point C. Okay. Now, ang hinahanap natin is compression. So, dito siya sa not PEG, PEE. Sorry for that. PEE at point C. So, ang kailangan natin is elastic potential energy niya at point C. So, transpose natin si PEG on the other side. So, we have here PEG at point A minus PEG at point C equal to PEE at point C. So, ito yung PEE natin. So, that means that we have here PEE or the elastic potential energy at point C equal to the gravitational potential energy at point A minus the gravitational potential energy at point C. And we have the variables. We have 1 half k x squared equal to 1 mgh rather mgh at point A minus mgh at point C. Okay, continuing on, we need to determine the compression at x. Okay, so solving for x, we transpose 2 on the other side. So we multiply the whole equation by 2, which will cancel 1 half here, giving us only k x squared equal to mass times gravity times height at point A minus mass times gravity times height at point C. Then transposing k, we have x squared equal to, so we divide the whole equation now by k, which will give us mgh at point A minus mgh at point C divided by k. And finally, removing the square, we get the square root of both sides. So we'll have x to be equal to the square root of mg h sub A minus mg h sub C all over k. So we have x equal to, so let's factor out mass and gravity so that we will have less to compute, or rather less to write down. So we have mass times gravity times HA minus HC. So pinactor out ko lang si mg divided by k, or the spring constant. So we have x to be equal to the square root of mass of the roller coaster, which is 25 kilogram. So we have 25 kilogram times gravity, which is 9.8 meters per second square, times HA, or the height at point A, which is 50 meters, minus HC, which is 5 meters, divided by K, which is 5,000 Newton per meter. So we have X to be equal to, the value of X should be 2.1 meter. Okay, so I have question number 8. What is the magnitude of the tension P force pulling on the foot in the traction device seen in the figure? So this is a question on statics. So in statics, since there is no motion, assumed no motion, so we only have the forces acting on the object. The problem here is that this is multiple forces and uh, rather multiple forces on multiple points. So hindi natin pwedeng i-assume na pare-parehas ang epekto niya. Okay, for one thing. But what we do know is that the weight of 40 Newton will cause tension here. So we could assume that tension here would be equal to W. So that string is connected to this string here. So that means that on this string, we also have weight as a tensional force. And on the last string here going up, so nakita nyo, may W din siya. That means that that weight will also provide tension on this force. So yung tension niya dito, tension din dito, tension din dito. Kasi iisang string lang sila. That's the rolling with uh, tension through a pulley. Okay? So the tension remains the same. On the other hand, this string here, which is connected to the foot, is not connected to the string pulling the weight. So that means that it has a separate tension as compared to the other string. Of course, meron din siya, this is a bar, so hiwalay siya ng konti, yung tension, yung compression or tension niya. Meron siya actually tension din siya, pero hiwalay naman siya. Ang inaalam na natin is the tension on the foot. So solving for this, we have the summation of forces along the x. So let's try to solve this. The summation of forces along the x on this pulley. Kasi yun lang may kinalaman sa tension. Dito hindi natin kailangan. Kasi we could assume that the weight is the tension here, which is the tension also here. So parehas lang siya. So meron lang tayo yung tension at this point. So at this point, dito tayo maglalagay ng Cartesian plane. Okay? So maglalagay tayo dito ng Cartesian plane at dito tayo mag-draw ng ating summation of forces along the x. Okay? So statics yan. So inuli ko, statics, no motion. So the summation of forces along the x and the summation of forces along the y should be equal to 0. Actually, may kulang pa to when we deal with statics. In statics, is hindi lang summation of forces along the x, hindi lang summation of forces along the y. Kasi there could be unbalanced forces on both sides along the x and along the y. But still, mag-i-equal pa rin sila. Iba, pwedeng summation of forces along the x and summation of forces along the y be equal to 0. Pero may paggalaw pa rin siya. Kasi meron tayong tawag na torque. So, importante din, pagka statics is that summation of forces on the, summation of torques on the equation should also be equal to 0. Kasi pag merong force na magkakos ng torque, that torque is rotational. Parang sa swing. An unbalanced force on a torque will cause that body to rotate. So, importante din yon. So, later on other problems, tatry natin yon. So, this time, meron na tayo along the x and along the y. So, if we try to draw the Cartesian plane, or rather redraw the Cartesian plane without the bodies, we have the following. Tension, dito, which is tension here. And of course, we have the tension on the, due to the weight on both sides. So, meron tayong tension at an angle of 30 degrees. Tension due to the weight. And another here, tension also due to the weight. So, these are two tensions due to the weight. So, since this is statics, along the y, we have the same tension along TW. So, this is TW along the y. this is also TW along the Y, which is equal. So it will cancel each other out. And it has no effect on the tension T. So inalam natin is etong tension na nandito. So along the Y, hindi natin kailangan i-solve. But rather along the X, yun ang importante. The tension along the X or the summation of force along the X is that we have tension which is negative plus TW, let's see that's TWA going up and TWB going down. Also to the left, no, to the right rather, to the right. Pareho silang positive and equal silang dalawa. Okay? So we have here equal to 0. So we have tension. So let's remove T here. So para hindi tayo malito. We have the weight A. Nilipat natin si tension sa kabila, magiging positive. Then pinagpalit natin ang pwesto. So tension is equal to the weight A plus weight B. So, para sa hindi kayo malito, i-rewrite natin. So, nilipat ko muna tension weight A plus tension weight B equal to tension. Yan, ito yung sumunod. Okay? Ito yung sumunod na step para hindi kayo malito. Tapos saka ko pinagpalit ng pwesto yung dalawa. Okay? So, ito na siya. So, hinahanap natin is WA plus WB. But rather, itong WA natin is WA X and WB X. Or simply that is WX plus WX kasi parehas lang mo yan. Pinaghiwalay na natin yung A and B pero parehas lang sila. Ano na yung WX? WX is W cosine of 30 degrees. Kasi ito si theta natin which is 30 degrees. Ito si WX. It is adjacent to theta. So that means that is WX is W. So pagsamahin natin WX is 2. That's 2WX. Ano yung WX natin? WX is W cosine of 30 degrees or cosine of theta. And W is 40. Okay. W is 40, so that is 2 times the 40 Newton. So, hindi siya weight, hindi siya mass rather. 40 Newton times the cosine of 30 degrees. So, the tension should be twice 40 Newton times cosine 30 degrees. And if you calculate that in our calculator, that would be equal to roughly 69 newtons. That's why the answer for number 8 is 69 newtons. Okay, next number. Number 9. So this time, it is still statics. But as I have told you, in statics, tatlo ang summation na kailangan natin gawin. We have the summation of forces along the X, summation of forces along the Y, and summation of torque. Okay? Kasi pagka may unbalanced force sa torque, that force will cause that body to rotate. Parang sa swing. Pagka meron tayong swing, tapos hindi balance, at hindi balance siya, that force will cause the swing to rotate. Kasi naglili ka dito ng weight, pababa, may force ka, unbalanced force, wala nasa kabilang side. That force will cause it to rotate. Okay? Kahit pa meron kang equal force, meron kang equal amount of weight dito, pataas. Parehas silang weight, parehas na 40 kilogram. 40 Newton pataas, 40 Newton bababa. But the distance from the fulcrum has an effect. So, pwedeng magkaroon pa rin ng torque. Okay. So, the summation of forces along the X equal kasi 40 Newton siya. let's say for this problem, it's the same. Upward 40 newtons, downward 40 newtons. So summation of forces along the x y's that along the y rather. Summation of forces along the y since upward and downward siya. They are equal. It is equal to 0. But the distance from the fulcrum has an effect. It has an effect on the torque. Same ang mass nila or same ang weight nila. Magkaiba sila ng distance from the fulcrum and pares lang on one side. That will cause an unbalanced torque, which will in this case will cause motion. Kung ito nilagyan natin 20 Newton, pwede pa. Mag-balance pa rin siya. Pero dito, hindi siya balance. Okay. Now, to solve for this problem, hindi lang siya ay magagawa ng Cartesian plane. Actually, dati kailangan ng Cartesian plane. But rather, ang free body diagram natin is the torque, which is the distance ang kailangan natin. So, from the what to call this? From the fulcrum, ito yung point of rotation niya. Dito siya iikot eh. From the fulcrum, meron tayong dalawang forces. We have a force. First is the weight, which is going down, which is 100 Newton. And we have tension, which is at an angle of 37 degrees. So, meron tayong tension. But mind you, this tension has two components. Okay? It has two components. We have tension. We have tension along the x and along the y. So, along the y, meron tension dito. P sub y. Meron din tayong P sub x going here. We have P sub x. Okay. What is notable about torque is that if we project the force and it passes through the fulcrum, that force is null. Walang epekto. Like kunyari, ito yung pinto. Let's say ito yung swing. Mag-apply ka ng force dito, walang epekto kasi dumaan siya sa fulcrum. Ganun din kay X. Any angle, pag dumaan sa fulcrum, walang epekto dahil sasaluhin lang siya sa fulcrum. Katulad nitong X, kung i-project natin to, that Tx will pass through this fulcrum. Ito kasi yung fulcrum niya. So that P sub X will pass through the fulcrum and it will have no effect. Ang effect niya, possibly compression. Okay? May compression siya. So, meron siyang force along the X. Magkoko siya ng compression. Pero that's a different story. Ang problema natin is the tension P sub Y. Okay? So, P sub Y, here, ano yung magkoko sa kanya P sub Y? So, the tension here, P sub Y, should be equal to should cause rather torque. Okay, so the summation of torques. Okay, so the solution here is that the summation of torques should be equal to 0. And ano naman meron torque tayo? So when we deal with torque, torque is the force perpendicular to the distance from the fulcrum multiplied by the distance from the fulcrum. Okay, so this means this is perpendicular to the fulcrum, perpendicular distance from the fulcrum. So we have weight times the distance from the fulcrum. So in this case, this is 0.6 meters. So that is distance 0.6 meters. So this is clockwise, this is counterclockwise. So yung counterclockwise is negative. So positive CW minus CP sub Y times the distance from the fulcrum from the equation 0.6 0.3. So this is 0.9. So times 0.9 meters. Okay. So hinahanap natin is T. So kukuha natin T sub Y. So we have here T sub Y times 0.9 meters is equal to the weight times 0.6 meters. So T sub Y, or rather T sub Y is T. We have here angle theta here, which is 37 degrees. The T sub Y is, if we project T sub Y on the other side, nilagay natin dito si T sub Y, the same height, so same ang magnitude. It is opposite the angle theta, so opposite is sine. So that is T sine of theta times 0.9 meters equal to the weight times 0.6 meters. So the tension should be equal to the weight times 0.6 meters divided by 0.9 meters times the sine of theta. If we put the values, we have tension equal to the weight, which is 100 newtons, times 0.6 meters divided by 0.9 meters times the sine of 37 degrees. So the tension would be approximately 110 newtons. Ang ating tension. I'm sorry kung nagkamali ang unit. So that's 110 newtons. It's question number 9. And lastly, number 10. So for number 10, this is, the problem here is in impulse and momentum. So in impulse and momentum, the impulse I should be equal to the change in momentum. Okay. So this is the change in momentum, or that is mass times change in velocity. And what is all impulse? Impulse is also equal to force multiplied by the time that that force is applied. Okay. So this is equal to mass times change in velocity. So pag-equate natin dalawa. So ang hinahanap natin is how much force is felt by the passenger. So force ang hinahanap natin. So that is force is equal to the mass of the body times the change in velocity divided by the amount of time that that force is followed. So, ang given natin sa problem, is the initial velocity, which is 27 meters per second, the time, which is 0.2 seconds, time 1. We have time 2, which is 2.5 seconds, and the mass of the body, which is the weight of the person, which is 860 Newton. Okay. So, ang hinahanap natin is the force being felt. So, ang kaibahan dito is that the force being felt is against motion. Okay? Kasi pagka sa airbag, saka seatbelt, ang motion ng body, ito yung motion. Siyempre, ang airbag, saka yung seatbelt, it is restricting us from moving. So, papigil siya. Parang friction. So, that means negative ang kanyang epekto. So, let's try to solve for that force. So, ang required sa atin is the force felt by uh, force felt by the passenger on the so the required here is the force felt from the airbag. Okay. So the equation that we will be using, nakalagay naman sa screen, we have force is equal to the mass of the body times the change in velocity divided by time. Or in other words, that is the change in momentum divided by time. So, we put in the value, the mass, since weight ang given, mass is equal to, weight is equal to mass times gravity. So, mass is equal to weight divided by gravity. So, this means that this is weight divided by gravity multiplied by the change in velocity divided by time. So, almost lahat given. So, anong gagamitin natin time? Is it the 0.2 seconds or the 2.5 seconds? So, in our problem, yung passenger was stopped at 2.5 seconds. At hindi naman naka-apekto yung seatbelt sa airbag sa kotse. Naka-apekto siya doon sa passenger. So, ang importante is, ano yung epekto ng airbag sa passenger? So, anong time bago tumigil yung passenger? So, ito yung gagamit natin, 2.5 seconds. So, the force is equal to the weight, which is 860 Newton, divided by gravity, which is 9.8 meters per second square, times the change in velocity, which is the final velocity. Dahil tumigil siya, it stops in 2.5 seconds. So, 0 ang final, minus initial, which is 27 meters per second, divided by time, which is 2.5 seconds. So, the force felt is negative 947.76 newtons. Ito yung naramdaman. So, medyo malaki pa rin. Yes. 947.76 newtons. Dahil doon sa seatbelt sa airbag. What if kung walang seatbelt? If walang seatbelt saka walang airbag, possibly, the passenger will stop at the same distance, the same time, natitigil si kotse. 0.2 seconds. So, kung gamitin natin yon, if we try to use that, okay, if we try to use that, the force would be equal to the mass times the change in velocity divided by time. So, time A, time 1, gamitin natin time 1, 0.2 seconds. Actually, mas mabilis pa dyan eh. So, the force that will be felt by the body pagka tumama tayo sa dashboard will be yung mass, which is yung 860 Newton divided by 9.8 meters per second square multiplied by 0 minus 27 meter per second divided by time, which is 0.2 seconds. So if we compute that, that will be equal to negative 11,846.94 Newton. So mas malaking force ang mararamdaman pag wala tayong seatbelt. Imagine, 11,000. That's almost 10 times ng 1 tonelada. So ganyan kabigat ang mararamdaman natin. So that's the amount of force pag wala tayong seatbelt. Pag may seatbelt, 1/10 lang. 947.76 newtons lang. Okay? So mahalaga pa rin ang may seatbelt. So always remember, wear your seatbelts. Okay? So that's it. Thank you very much for attending our lesson, and I'll be seeing you in school para sa mga other lessons natin. Okay, thank you.